last 3 lecture sessions, we have been discussing various aspects of theory of constants or the TOC approach. So, by this time you have come to know what are the main issues involved in theory of constants and if you want to implement TOC approach in your production systems at your plant, then what actually you are supposed to do. Now, in the last lecture sessions, we have also mentioned that what are the specific TOC principles you have to follow. So, altogether you can identify some 10 specific principles, and by this time you are aware of, you are familiar with all these principles. Now, during this lecture session, the 4 specific issues related to say the development or implementation of TOC approach in a manufacturing system we are going to discuss. So, let me first tell you that what are these specific issues we will be discussing at this point in time. The first one is how to achieve continual improvement of system performance using TOC approach. I have already mentioned that it's a continual so the improvement approach, and what you try to achieve, you try to achieve the best possible system performance. That means you are not satisfied with the subsystems performance. So, while you go for improving the system performance, you need to consider definitely the subsystem performance, and then considering the interactions or interdependency between the subsystem say the performance. What you need to do, you must have the best possible optimized system performance. So, what is the procedure you employ if you have the TOC approach? So, this what are the steps to be followed? So, this aspect we will be discussing first. Next, we will be referring to the so called drum buffer rope scheduling. As I have already pointed out that that the TOC approach is referred to as a scheduling approach, and particularly one say particular type of scheduling systems which is referred to as the drum buffer rope scheduling. So, you should be aware of. So, we will discuss in detail what is the scheduling approach, and then what are the steps involved in the DVR scheduling. So, you should know what are the steps, how to define them, what is its implication, and by using this DVR scheduling, to what extent you get a condition where the smooth flow of materials within a production system is guaranteed. And towards the end, we will be referring to different types of production systems, and as per when you try to apply the TOC logic or TOC approach, you need to define, or you need to say the classify the production systems in a particular way. So, how and based on this classification approach, what are the types of production systems you come across, and what is required, what is needed is for each type of production system, how do you say the implement, how do you develop say the TOC approach. So, all these the 4 issues we are going to discuss now. Now, the first issue is how to achieve continual improvement of system performance using TOC approach. So, here is it is explained with a flow chart in closed loop. So, there are several steps, and you have to follow these steps and in a systematic manner, and you have to define say all sorts of say the variables, all sorts of parameters, all sorts of outputs at each of these the steps involved. So the first one which you find, that is identification of the constraints. Okay, so that is your first step. So the starting point is, say obviously you start with the internal constraints. Okay, and many a time the internal constraints are referred to as the bottlenecks. It creates bottlenecks. So you start with identifying constraints, and the constraints are related to the resources, and obviously based on these constraints you need to identify the capacity constraint resources. Okay, so this is the first step, and what sort of say the approach you follow for identification of the constraints. So this is an important issue, and you know that you are familiar with several examples of constraints, and so these constraints are to be identified, and entire for the plant or for the production system which which is under consideration, where TOC is to be applied. That means what are the resources, and where these constraints are really a problem, and what are the bottleneck resources. Now what you try to do, the next step is you need to optimize constraints output. That means supposing at a particular resource, that resource is considered to be a bottleneck resource, and it is not only bottleneck, it is also a CCR. Okay, so so the capacity constraint the resource, and what you try to do, that means that the first step should be how to improve the performance of say the constraint resource or the bottleneck resource, CCR. So that is your starting point. At any point in time there could be a number of such constraint resources. So out of all these constraint resources, which one is the most severe, which one is the most critical. So, and then what sort of say the measures you need to take to improve the performance of this constraint resource. So that is your first step, and it is expected, if you follow the steps as we have discussed in the previous lecture sessions, if you follow those steps in a systematic manner, it is expected that you can optimize the constraints output. So output in the sense that the output is nothing but the throughput. Okay, it's not that you just you produce for activation or for utilization sake. That means whenever you say that I want to have the best possible, or so the maximum utilization of a particular resource, and in this case it is basically the CCR. So what you try to do, that means you focus on utilizations, not only the activation. That means this output will have a direct relationship with the throughput. So we have already mentioned what is a throughput. So all these details you should look into. So it is expected that if you follow the steps meticulously, systematically, you will be achieving these conditions. Next, what you do, that means this is say the one particular critical resource you consider, and you and as per the requirements of this critical resource, you try to produce say the related say the inputs or the outputs of other resources, and make sure that that these subordinate all decisions to constraint optimization. That means as we have pointed out, like say a bottleneck resource is essentially it will guide the other resources, non-bottleneck resources, in terms of actually what is the how much it is our non-bottleneck resources are supposed to produce as per the requirements of the bottleneck resources. So, this principles you have to follow, and this is referred to as subordinating all decisions to constraint optimization. Okay, and then you expand the constraint. Okay, so so as far as the possible, you need to expand the constants. Then you just check whether a particular constant is still active or not. That means if it is no, that means obviously now one problem related to one constant is over. Obviously, in the next period of time, you will have another constant, and you follow the same steps so that that particular the next constant is ceases to exist. Is it okay? And if suppose the constant is still active, then you need to further optimize the constant's output. That means you are proceeding in right direction, but you have not reached a maximum level of performance. Is it okay? So this is the flow chart, and with this approach, it is expected that you will go for continual improvement of the system performance. Okay, so that means you can what you can do, you can set different the targets at different points in time, and you check whether you are achieving those targets or those goals or not. Okay, so so this is the general approach. So now in a given situation, what you try to do, that means this generic approach you have to follow, and you have to apply this generic approach in a particular case. Is it okay? So what are those specific constants? How many constants you have been dealing with for the last couple of years? So that sort of information you will have, and there must be specificity in your whole approach. So this is the first step you do. Now, as so more or less now by this time you have come to know that what is a TOC approach, and how do you say get the optimized system performance applying the TOC approach, and it is a continual improvement philosophy, and mainly applicable for repetitive manufacturing. And what is most important is that you know the flow of materials within the production systems or the manufacturing system, the flow should be very smooth, and you must have sufficient control on this flow. That means even if suppose this flow of materials is disturbed, you must know that what are the possible reasons, and you must be very responsive, or say, and as quickly as possible the corrective measures you must be able to take. So essentially it talks about scheduling, and this scheduling, that means the TOC based scheduling, many a time this is referred to as the drum buffer rope scheduling. Okay, so please note down this the name, drum buffer rope scheduling, or in short it is referred to as DBR scheduling. Okay, so the working of TOC approach, you already know that what is that flow chart. So if you look at this flow chart, which you have already explained, you will come to know the working of the TOC approach in specific terms. So the working of TOC approach closely resembles a scheduling system. This point we have been already say the mentioning, referred to as drum buffer rope scheduling or DBR scheduling. Now what is a DBR scheduling? Now it is essentially it is referred to as the logistical system. Okay, because it's a logistical systems, and you know overall what we will trying to do in the next the lecture session, subsequent lecture sessions, will be referring to the logistics and supply chain management. So, so you're just getting into say the logistical systems. So this logical system is a finite scheduling technique, balancing the workflow in the system. Okay, so this point we have been telling you all the time. It attempts to control the flow of materials within a plant in such a way that it meets the market demand with minimum inventory and operating expense. So, as per the TOC, the logic, you know what is inventory and you also know what is the operating expense. It identifies all types of constraints related to the three aspects: processing, resources and marketing. So the marketing actually that talks about the demand generation, okay, and that's why what are the constraints related to marketing you must know. Then you have been using several kinds of resources. We have already defined what is a resource. So related to a particular resource, what sort of the constraints right now you are facing, so you should be aware of. You have already come to know the few examples of these constraints we have already mentioned. And similarly, while you go for processing the item or processing a particular, say, the product or the component at a particular resource, what sort of constraints you may be facing. So this list of constraints you must have with you. So that means first the step in developing such a scheduling approach is to get the data related to the types of constraints at the processing stage, at the resource stage, at the marketing stage. The objective is to get a continuous and smooth flow of materials to the plant with no or minimum disruptions. And even if there is a disruption, just make a note, there could be certainly there could be certain unforeseen developments, and because of this there could be disturbances, and now if there is some disruptions in the flow, now as quickly as possible you must be able to identify the causes, and you must be able to remove those causes so that you get back your original system and say the previous flow rate. Now when you talk about DVR scheduling, so it is also a systematic approach. Okay, so let me tell you what are the steps involved. Now essentially there are three interrelated steps: step 1, step 2 and step 3. Now let me tell you what actually you are supposed to do in each of these the steps. In the first step, or the step 1, you need to develop a master production schedule, or the MPS, matching with capacity constant resource, or the CCRs. Okay. Now we have already defined what are the CCRs, and we have also mentioned a point that the entire TOC approach the starts with the identification of CCRs. So this is your first exercise. So assuming that the CCRs are identified, now what you try to do, you develop the master production schedule in such a way that MPS matches with the CCRs. So this is very, very important. That means your base is CCR, and based on the CCRs, the requirements, you go for developing the master production schedule. When we discussed the MRP, we mentioned about the MPS, and that is one of the inputs of of MRP system you are already aware of. And what is my suggestion is that you refer to a typical say the master production schedule format, and this is universally followed. So that is the first step we have to do. That means you have to develop a master production schedule as you do for MRP system. It is equivalent to a drum that establishes production rate for the system. That means when you create the MPS, definitely you will be aware of that what is against a particular item, what is its production rate, and it is equivalent to of creating a drum. Okay, so the drum is indicative of the production rate for the system. Is it okay? At which rate you should rotate the drum. So that is the basic idea. So that's why it is referred to as the drum. Now once the drum is created, that means master production schedule matching with the requirements of CCR, then you go to step 2. In the step 2, what do? You ensure the production of throughput. Okay, this is the throughput by controlling the effect of statistical fluctuations or the variability with the use of time buffers at critical locations. That means when you what you will come to know, that means you need to represent your production system in a particular manner. So very soon you will come to know. Maybe in the next lecture sessions I will discuss the types of production systems. And while I discuss this the types of production systems, you will come to know that how a particular production system is represented. So once this representation is made, you will come to know what are the critical locations. What are the critical locations where you need to control the flow. Now it has got two dimensions. One is the quantity, definitely, and the second one is the timing. At which point in time, during which period of time, you need to decide the production rate. Is it okay? And over the time periods, the production rate may vary at a particular location. So sometimes at a particular location, the no units are required. So you wait for the next time period. Is it okay? So sometimes this is referred to as the time buffer. Okay, so that is very important term, and the time buffer, this particular term already we have used while we explained the MRP system. Now two important aspects you need to consider in at this step. The first one is you need to produce only the throughput. Okay, so throughput production must be assured, and the second one is you need to control the statistical fluctuations and variability. Now how do you control it? Obviously you start using the time buffers. Okay, so you wait, or immediately in a particular time period you improve, or you need to have more number of units subsequently, or to be these units to be sent subsequently to the next stage. So with the use of time buffers at critical locations, so you take care of or you control the effect of variability. It also ensures meeting due dates of the throughput. So throughput is essentially the quantity which you can sell. That is very important in fact. But at what point in time you are selling it, that is also very, very important. Are you in a position to meet the due date? Because so the due date, the meeting the due date is one of the say the important criteria in scheduling. Is it okay? So many a time there you apply the priority rules for the jobs of scheduling, and in this case particularly one priority rule, okay, you must be able to satisfy, or you must use, and that priority rule is actually meeting the due dates, okay, or expected due dates of the throughput. Once this is done, That means at the first step the drum, at the second step the creating the time, let's say the buffers or the critical locations of the production system, and next you move to the step 3. That means when you reach step 3, the variability is under control. You can use the time buffers to control the flow, and you are in a position to produce the throughput only, and you are also in a position to meet the due dates. Is it okay? So that means what you can say, that once you are successful in implementing step 1 and step 2, that means the entire production system is more or less under your control. Then you move to step 3. Tie the production rate for the CCRs to each resource by using time phase logistical ropes. That means with the rope, what you try to do, you try to the control the rotation of say the drum. So this is referred to as the ropes, and the ropes synchronize all non-CCRs to help timely release of required materials with required quantity at required time into the system. Now you are definitely looking at the CCR, but then the CCRs are the dependent, working of the CCRs are dependent on working of the non-CCRs. Okay, and similarly, the bottleneck resource performance is closely related to what extent you get at what point in time and which quantity you are fed from other non-bottleneck resources. Is it okay? So obviously there will be time buffers, and there will be the controlling of the quantity as an inputs, as well as from the output from say your say CCRs or the bottleneck the CCRs. So this is essentially it is referred to as the fine tuning, and it's like the controlling through ropes. So as we have already pointed out that with the application of TOC approach, you need to essentially you need to create a synchronous manufacturing system. So these ropes are synchronizing all non-CCRs to help timely release of required materials, okay, with required quantity at required time into the system. And the required time means due dates that if that are pre-specified. Ropes ensure that the product flow is maintained from upstream to CCRs and subsequently to downstream operations. That means behind the CCRs you have the upstream processes, and beyond the CCRs you may have the downstream processes. So what is the role of a rope? That means a rope ensures that the product flow is maintained, proper product flow is maintained, and so that the system performance is guaranteed. Now, so what we conclude, that with the DBR scheduling, establishment of a synchronous manufacturing system is the main objective of DBR scheduling. Hence, the buffer protects CCRs from any kind of disruptions, and the rope ensures timely release of raw materials into the systems. So I repeat, the buffer protects CCRs from any kind of disruptions. Okay, it's like a safety stock. It gives you protection. Okay, sometimes you need more quantity, sometimes you need less quantity. So accordingly, you create that buffer. And quantity, definitely one aspect, and the second most important aspect is the timing. Otherwise, the condition of, or say the smooth flow of materials, this condition you cannot maintain. And what is important is the rope ensures timely release of raw materials into the systems. Is it okay? So this is also very, very important, both quantity and timing. Now, in this context, identification of scheduled release points out of many possible release points in production system is a critical issue. So, you just make a note of this particular say the term called scheduled release points. So, when you represent a particular production system with a diagram and where the interrelationship between different stages are highlighted. Now, the first thing you need to do for application of DBR scheduling, you need to identify the scheduled release points. As only the scheduled release points are tightly controlled, okay, there may not be any need for close control of other points. Definitely, there may be n number of such the release points, but out of these the release points, which ones are considered the scheduled release points, okay, or the critical the release points, you need to identify them only. 4 categories of scheduled release points. At this point in time, you must know that how do you categorize these release points. First one is the raw materials release points. This is very, very critical, in fact, okay. Then the CCRs, okay, all the CCRs you need to identify, and all these CCRs are critical release points. Then the assembly points, okay, because assembly points are very critical in the sense that you must ensure the supply of say the required quantity of materials as well as the timely release of such materials to the assembly points. Is it okay? And similarly the divergent points. Okay, so these are the 4 the categories of scheduled release points: raw material release points, CCRs, assembly points, and divergence points. In this context, the location of scheduled release points in the flow depends on the types of production systems. So, under TOC, the production systems are grouped under 3 categories. So, one is the V plant, the second one is the A plant, and the third one is the T plant. So, as we have been pointing out that entire production system for which you are going to implement TOC. So, the production system has to be represented in a particular manner. So, the 3 ways you can represent a particular say production systems, and and accordingly 3 types of production systems or the plant we have. The first one is referred to as the V plant, the second one is referred to as the A plant, and the third one is referred to as the T plant. Now, before I conclude this session, so let me define what is a V plant, what is let me explain what is a V plant, what is an A plant, and what is a T plant. A V plant has a V-shaped or divergent process flow, okay, is a divergent process flow, and has a single or a few raw materials. That means is the starting point over here. Either one material you start using at the first stage, raw materials stage, collection stage, either one say the raw material or a few, 2 or 3 types of materials you are going to use, and a wide variety of end items. That means as you proceed further, you come across several stages. That means it is a divergent flow, and so that's why it is referred to as the divergent process flow or A type. Alternative to V plant, we have you may have A plant. In the A plant, what you do? It is an A-shaped or convergent process flow. That means you have been using several types of raw materials, and all these raw materials are further processed, and ultimately you reach to the final stage where out of all these raw materials you are going to produce a single end item or a few end items. So, it is essentially a convergent process flow, okay, as an alternative to say the divergent process flow, which is referred to as a B plant. So now you may have the A plant. Is it okay? Now next what you may have a T plant where a T-shaped or divergent process flow with limited number of components or sub-assemblies that can be combined into a large number of end items. That means what you have, that means you have few kinds of raw materials, and with these few say the raw materials, when you process it in a number of stages, now you have a set of components or sub assemblies, and by combining all these components and sub assemblies, you can have a large number of or substantial the number of say the end items. So that's why it is referred to as the T plant or the T-shaped or divergent process flow. For any plant, there are interdependent activities. As it is a discrete part manufacturing systems, the flow of materials across the series of interdependent activities may be affected negatively due to three main reasons: overactivation of resources, that is one. Similarly, the misallocation of resources, so that may create a lot of disturbance in the systems as far as process flow is concerned. And similarly, the misallocation of materials, these also may affect adversely the process flow. So with this with these explanations, now you have come to know that what is the DBR scheduling, and what are the basic conditions you have to fulfill, and for implementing DBR scheduling at your production plant, and what sort of the control features you have in the DBR scheduling, and with these control features, how do you get a conditions where the smooth flow of materials is guaranteed. And for that you need to say represent your production system in a particular say in the format, and the three formats or three specific structures we have mentioned, that is B plant, A plant and T plant. So thank you.